Hi everyone! This is a video tutorial about aromatic compounds. So we're basically going to look at the three characteristics that make a compound aromatic and how you can apply that to an example to determine whether or not a specific compound does fall in the aromatic bracket. So if we take a look here, you'll see that we have three basic rules for an aromatic compound. The first one is it has to be cyclic. So it could be a 3-membered ring or a 6-membered ring, but as long as it is a closed cycle. The second thing is it has to be planar. So any and all atoms involved in that cyclic component of your structure, even if it's a bigger structure, have to be sp2 hybridized. The third and final piece is that you're going to have an odd number of pi cloud electron pairs. So let's see what this looks like in practice. Okay, so now let's systematically apply these three rules to each of these four compounds to determine whether or not they're going to be aromatic. So if we take a look at this first compound here, we see that it meets the first criteria. It does have a cycle in it. The second criteria is that it has to be planar. And if we take a look, all of the carbons that are participating in this cycle here are sp2 hybridized, which would mean they would be planar. Remember that this carbon here, even though it's sp3, doesn't impact our aromaticity because it's not directly part of this ring. The third rule is that we need to have an odd number of pi cloud electron pairs. So here we have 1, 2, 3. So this one meets all three criteria, so this here would be an aromatic compound, a really stable compound. Let's take a look at the second one. So it's got the cycle, so good on the first criteria. The second one has to be planar. So we can see that all of the carbons that are participating in those double bonds would be sp2 hybridized. These ones here, though, would not. They both have two hydrogens implied coming off of them, so they would be sp3 hybridized. And because of that, this would not be a planar cyclic compound, so this one here would not be aromatic. Let's try again on the third one. So here, cyclic, it is. It may look like a square, but that's still a cyclic compound. The second criteria, planar. All of these carbons are sp2 hybridized, so we're doing well so far. The third criteria, an odd number of pi cloud electrons. In this case, we actually have 2. So this would be a different kind of compound, and it would be called anti-aromatic. So whereas aromatic compounds are particularly stable, anti-aromatic compounds are particularly unstable. So this would definitely not fall in the aromatic category. And the fourth and final one here, we see cyclic, so we're meeting that criteria. The second one, sp2 hybridized. So this would be sp2, 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 and sp2. This one here kind of defies expectation. So this would have a hydrogen coming off, and if you counted, you'd have 1, 2, 3, 4 areas of electron density, which is typically going to be labeled sp3. But now this is the thing, right? We have all these rules to help us understand molecules, but they don't follow our rules, and they do whatever leads to the greatest stability most often. So in this case here, if this one adopted an sp2 hybridization, then it would have 1, 2, 3 pi cloud electron pairs, meaning that would make it aromatic. And that actually is what this compound does. So this one may not look it initially, but this one would fall under an aromatic heading. So that's pretty much how you apply the rules to understand whether or not a compound is aromatic.